Well, welcome everyone. Thank you all for joining Did You Know, the ESCO HVAC Show. Let me ask you a question. Has anyone ever explained to you how communicating HVAC systems work, what principle they come from? It's a very important topic that we really don't talk about a whole lot in the industry, and that's what we're here today to do, is discuss how communicating systems work and get a better understanding of what that communicating thermostat does in relationship to the entire system. If we look at communicating systems in general, they really do have their roots in the same technology. I'm not going to say that they all talk the same way. We'll just say that they talk on the same network, and they may speak slightly different languages, but they all have their roots in the same type of communicating system. If we look at this reference from Eaton will tell us that the RS-485 system has been around for a very long time, really developed back in the 1980s, and it's based on a 5-volt DC two-wire principle, two-wire communicating system. It could be up to 4. Most of the time we're using 2 wires to develop that 5-volt DC signal, but it is in reference to a ground or a common landed ground. And we have a positive signal that is in reference to ground and a negative signal that is in reference to ground. So how do we get to that point? Well, it's really not that complicated. It's very ingenious, but not incredibly complicated. We take our AC power source, starting at the furnace or air handler, our indoor unit, which is where our power source originates typically, right? That's where the power supply is. So we take our AC signal, we run that through some bridge rectification. We run it through diodes. We get that rectified into a DC signal, a reduced DC signal at about 5 volts DC. Then we will add a grounded reference point to it. And the network that we're going to talk about today, which is the Climate Talk network, which I would say that many manufacturers use this principle, we land that ground not exactly in the center of that 5-volt DC span. Remember, it's 5-volt DC, the height distance of our sine wave. We land it off center so that it is not directly in the middle of our reference point. So what we end up with in those 2 points is a 5-volt DC signal that is partially positive in reference to ground and partially negative in reference to ground. So now we have a place that we can start. Well, when we talk on that, we're not going to be able to listen in on what's being said on that, but we can verify if our network is working properly so that we can start looking for issues, right? So if we reflect back on this RS-485 platform, and we can see here in the little red square that it is a 2-wire data function primarily. This one is going to call it data plus and data negative. And then we might have our common and our ground, which is for our communication cable. But the work is really being done on those 2 terminals. Now, let's look at a couple different manufacturers, and we'll try not to use names on these. If you are a technician that reads your service and installation manuals, these wiring diagrams will look different. They're coming from different manufacturers. This particular one is actually the one that we'll talk about the most today, but let's hone in on what that communicating looks like from this manufacturer. We can see there where I put that little red square on our diagram, we are going to have a data line 1, a data line 2, then we're going to use 2 additional wires for 24 volts hot. Well, what are we doing that for? Well, our 24 volts hot, R and C, is the amount of current, the higher amount of current, the power that we're going to use to run that big fancy colored LED screen. It's also going to give us our capabilities of running Bluetooth and Wi-Fi and any type of a load that is on our controller. Data 1 and data 2 are going to be our 5-volt DC signals that we are going to use to communicate. That is our parallel communicating network. Well, let's look at another manufacturer. If I look at this wiring diagram, I go, my goodness. I have another positive and negative signal, and I'm using a common, so a ground reference point. So this particular manufacturer is using 3 wires. It is using common, which is a grounded common. So that is our ground reference point. It has a positive signal on A in reference to ground and a negative signal on B in reference to ground. If we look at this manufacturer, they are also using a 4-wire connection, but you'll notice they're using common and 24 volts AC for the load that is on the controller, and we're using data A and data B. It just happens to be our DC communicating signal. We look at this other manufacturer. If you look there in that little red square, we'll see that we have our common and our 24 volt AC load. And then now we have, this one is labeling it as I negative and I positive. Looky there. We have a negative reference and we have a positive reference once again. If we look at this one, we're going to see a 4-wire connection. 2 of those 24 volts AC and 2 of those labeled as a positive DC and a negative DC. So we look at this manufacturer, another reference of the exact same thing. So I'm not saying that all manufacturers use the exact same, because I have seen some variations of it, but I will say that the philosophy, the technology behind it all comes from a similar design. If we look back into the early technology of communicating systems, we will find this reference to the Climate Talk Alliance. The Climate Talk Alliance was a group of manufacturers that knew that technology was coming. 1990s, late 80s, early 90s. And they knew that we were going to have more communicating systems in the industry, not just in the HVAC, but in the HVAC, refrigeration, and appliance sector. So many manufacturers got together and decided, hey, maybe we should have an open protocol going forward so that we can all talk on these same channels and so we don't all get mixed up along the way, and technicians can have an easier opportunity to know how things function in this new communicating platform. Well, it happened for a few years, a couple of decades or so, and then it slowly started fizzling out as many manufacturers started creating their own coding used on their network. But the network itself is why we're here to talk about. The network is something that we can understand, and we should understand. I got my first opportunity to dive into this communicating network back in my distributor days when I was doing teaching on a particular brand of communicating equipment. And I ended up with this amazing controller called the EWC Excellence Without Compromise UT-3000, or the UltraTalk 3000. And it is the only communicating zone control system that works with the Daikin communicating systems, particularly like the Daikin Fit. So I got to know my good friend John Brown in that time. John Brown is the chief engineer for EWC, and he helped me understand this entire communicating network and how it all really comes back to understanding these DC communicating voltages and the things that can affect the path of our DC communicating voltage. And this really cool thing that just kind of blew my mind. The fact that that communicating thermostat doesn't necessarily have to be the brain, the control center of the equipment. One of the general philosophies in the field is that communicating thermostat is the one and only component of that network that does the actual work, right? That we replaced our legacy thermostats that just had switches that did the work with a communicating thermostat that did the work for us. And he really helped me understand it's not that way, that it is a functional network. And in some instances, you don't even have to have a thermostat connected to a communicating system for it to be able to function properly. So I would like you all to meet my good friend, John Brown. And John is going to walk us through a little bit of technology in the communicating world. Welcome, John.
Thank you very much, Clifton. Thank you very much. I really appreciate you allowing us to provide this information and increase the contractors' knowledge base.
Awareness.
Tech service managers, educators. This is going to be some important information. So we've got a lot to go on. So let's get started. Don't be afraid to chime in, ask a question anytime you like, interrupt us, no problem. We'll address those questions. We've included here some hyperlinks to some very important documents that you might want to, maybe you can capture a screenshot of this. Yeah. The UT-3000 Technical Bulletin, the Equipment Startup Guide, which is what we're going to review today using the UT-3000, a guide to using the UT-3000 to access the equipment menus, and then, of course, the Daikin One Plus Thermostat Guide. So these are some important hyperlinks. This will be shown, this slide will come up at the end of the presentation as well, so don't worry if you didn't catch them all.
And I'll also put hyperlinks in to the news presentation that I use for this, and as well as the YouTube video. I will do additional hyperlinks because these are all very important documents.
Great. Thank you. Okay. Now, this graphic you're looking at in front of you, of course, is a hybrid RS-45 communicating network, specifically for the Daikin communicating line of equipment. On the left, you see the outdoor inverter. This could be the FIT inverter or the original cube inverter.
Yep.
Notice in the middle, the indoor evaporator coil is no longer a TXV. It's an electronic expansion valve that also has a communicating circuit board. There's the communicating air handler and or furnace as part of the indoor package. And then on the lower right is the communicating block on the UT-3000 zone controller. Think of this block like if that was the communicating thermostat. The UT-3000 is essentially emulating a Daikin 1 communicating thermostat in that regard. Of course, above it, we do include the standard legacy output as well, because there's some guys who might want to hook up a hot water coil instead of electric backup heat, various ancillary devices that we can accommodate and incorporate into the communicating network. Now, what Clifton was talking about, extremely important here about these RS-45 networks, they are all roughly basically the same. What varies the baud rate which the data is moving on these networks, as well as the hierarchy of these networks. That is, who's in charge? Who's really in charge? As Clifton pointed out, it's not necessarily the thermostat. In this case, it's not even necessarily the zone controller. In this scenario right here that you're looking at, take the zone controller out of the equation, put a Daikin 1 right there on the lower right. The Daikin 1 thermostat is actually considered to be a subordinate entity on this network. The actual coordinator or the boss of this network, believe it or not, is the electronic expansion valve.
I know, blows my mind to think about that. Not even the indoor unit.
If you think about it, think about what an important role a thermostat expansion valve plays in a standard HVAC system. And it made sense that Daikin decided to make the electronic expansion valve the boss or the coordinator of this network.
Why not?
It knows what the superheat is, the subcooling. It knows what's going on and is coordinating all of this data with the outdoor unit, the furnace, the blower, the air handler, as well as the thermostat. The thermostat doesn't command and say, give me this. The thermostat says, hello, can I get a chance to talk?
Exactly.
When I get a chance to talk, I'd like to have 75% cooling, please.
Exactly.
And the EEV takes it from there. It's really astonishing.
It really is. And that's the thing to point out about that electronic expansion valve, that not everyone realizes that we are moving to electronic expansion valves to replace standard thermostatic expansion valves. But they are absolutely to our asset if we understand how they function. If we take this electronic expansion valve, I know this particular one, it has two temperature thermistors, one on the inlet evaporator, one on the outlet evaporator, and now we can start using a pressure transducer, a suction pressure transducer. And technicians go, oh my gosh, all that technology. And I go, what are you doing when you put your digital gauges on a piece of equipment? You are using by the way, a 5-volt DC pressure transducer to calculate the pressure of your suction so that your gauges have a number to work with. And we're also using a 5-volt DC potential temperature reading that we're going to measure the suction line. And now we have two mathematical numbers that we can calculate superheat with. Well,
exactly.
What doesn't it make sense just to put it at the electronic expansion valve and let the process begin at the component that does the metering? So if we know what the system is doing, if the system is functioning properly, we can read superheat without even putting a set of gauges on.
Exactly. The FIT inverter when you place it into charge mode, which we're going to show you later on how to use the UT-3000 rather than the thermostat to place the equipment into system test and charge mode, it will actually tell you whether the subcooling is proper or not, and whether you need to remove refrigerant or add refrigerant from the system itself. So it's really quite interesting.
Yes, it is.
Now, you saw the previous slide with the connections going from the zone control to each respective piece of equipment,
paralleling,
wiring in daisy chain, daisy chain configuration. We really would like for you to stick to that. Everything is in a row. You have an end to a beginning to the network and an end to the network, but not everybody wires in this fashion. Quite often, the data 1 and the data 2 wires from the outdoor unit, guys are just used to the old way of doing things, and they bring them over to the air handler or the furnace. Now, this is actually a star configuration. It's not a daisy chain or series configuration.
Sure.
So try to remember, wire everything in a row. And if you have different conductor types, that is, you have stranded going outside, solid inside, you can't put these two different conductors into a single terminal block because the cage is not going to capture both of them properly. So the image you see in front of you is a best practice. You got a stranded wire coming from the outdoor unit, a solid wire from the thermostat or the zone control. Fit everything on it. Make sure you don't twist too much and break one of those wires, and make a single point connection to the terminal block. Remember, low resistance connections is the key to keeping this network stable. So that's very important.
It is, John. One of the things that I had encountered with this exact same scenario is many a times with original solid conductor control wire. So we know if the application allows, technicians are going to flush a line set, they're going to reuse the original conductors, and it is acceptable if things are installed properly. One of the things we have to understand is with that solid wire conductor, that it might have passed current through properly on an AC load, because remember, our legacy thermostats had a switch and we were applying a load through that conductor for our thermostat wire. Now, when we get to work with our communicating systems where we're talking about a different impedance and we're talking about a low amount of current passing through the wire, if we have a lot of corrosion on that wire, it is not going to make a solid connection. So I always recommend for technicians on all communicating systems, if we have existing wire, especially if there's existing wire nuts anywhere, cut them off, re-strip down to fresh, clean copper, put the wire nut on, and then I always recommend to insulate those wire nuts with dielectric grease or with silicone so we make sure we don't get any moisture in there to create oxidation, which can cause future issues.
You're exactly right, Clifton. I ran into this on a job. Believe it or not, I got a call from Hawaii. Well, this guy's splice connection from the indoor to the outdoor was so corroded, it simply would not communicate with the outdoor unit. It took him a while to find it, but he did, cleaned it up, and it worked like a charm. Thanks for pointing that out.
Yeah, I always told guys, if they have an issue with the outdoor unit not pulling up onto the network and they're reusing wire, find the closest window or door, grab you a spool of fresh conductor wire, throw it outside, and run you a fresh new line.
We've actually done that.
Absolutely have done that. That's a quick way to find out.
Okay, so, installing a zone communicating system is challenging.
Yes.
There's no Y circuits to test. You can't use your meter to test C to W and stuff like that. So it can be a bit challenging. But the most important thing with this is this equipment needs to be commissioned. It needs to be commissioned properly. And you initiate the commission process typically through the thermostat. But we've seen some confusion in this, in that, sometimes the network doesn't configure. The thermostats can't find the equipment. The zone control did, but the stats didn't, or nobody can find the equipment. And we've also seen some issues where the commission process can be affected because the contractor doesn't have thermostats turned off.
Right.
Remember, commissioning, that is equipment test and charging mode, are commission functions. They're not cooling operations. So once these commands are sent to the equipment, they're forgotten about. If a thermostat in grandma's room is set to heat, the zone control is going to try to activate that.
Absolutely.
And you've got some dampers open and some dampers closed, which could inadvertently affect the outcome of your equipment test or your charging mode and your subcooling values.
Sure, your load across the evaporator.
Right. So what we've done is we've devised a way for the zone control to perform these functions for you without using the thermostats.
Not even connected,
Not even connected, Clifton.
Right.
The thermostats won't even be connected until the third part of the commission process. You'll see this later on. Now, of course, you got to install the equipment first, right? So you want to install your Daikin system, indoor and outdoor components, following the specific Daikin guideline and guidance. You want to include all required mechanical aspects, structural support, properly sized duct, a condensate removal system, a flue vent piping system, as applicable for the efficiency of your furnace, perhaps. Complete the refrigerant line set connections per Daikin guidance and industry standards. Make sure you put in a liquid line filter dryer close to the EEV, not outside anymore, close to the EEV to protect that component. Oil traps are important. Don't forget them. Connect your manifold gauges, evacuate the line set and the evaporator coil. When all the non-condensables have been removed, the line set and the coil are leak free, open the service valve per Daikin instructions. You're going to install the UT-3000 zone controller. Go ahead and mount the dampers. Do all the wiring for that, following the tech bulletin guidance from EWC Controls. Don't mount the thermostats. You've ran the wire. The plates are on the wall, but leave the thermostat right there on the table. Don't mount the thermostats just yet. Go ahead, route and connect all your electrical wiring. Just don't connect the stats.
Sure.
Energize, power up.
Power up the equipment.
Yep, power it up. Typical wait time is about 5 to 7 minutes for the entire network to configure. It varies. It can be 3 minutes. It can be 5, 6, 7 minutes. This is the typical wait time.
Sure.
What you want to look for, don't cover up the EEV circuit board.
Leave the cover off.
Exactly. Leave that off. This is the boss of the network. Remember, it's going to tell you if something's wrong. Okay. Right. So don't cover up the EEV circuit board. Also, pay attention to the LCD screen on the UT-3000. If the EEV board displays E77, the network has not configured. If the UT-3000 does not display a valid outdoor temperature, it says the outdoor air sensor is bad. Guess what? The sensor is not bad. It simply can't.
It's just not there yet. Yeah.
I can't see the outdoor unit. So some troubleshooting is going to be required. Not much, a little bit.
Yeah, absolutely.
So here's a shot of the EEV board. E77, meaning I can't configure the network. I can't talk to the outdoor unit.
So I don't see a complete system.
Exactly. This is a clue. The zone board might see the air handler. It might see the furnace, but it can't see the outdoor unit if it displays OAS bad. Now, believe it or not, I've had guys tell John, I replaced the sensor. It's still no, it's not the sensor.
The sensor.
It's the data wires going outside. The network has not configured. So, as Clifton pointed out, these voltages by equipment combinations and manufacturers can vary. The key is knowing what these voltages are supposed to be when all of your wiring is correct.
Yes.
Okay. So an air handler with a built-in EEV coil, that is, or a cased coil, and the fit inverter, your common to one, that is chassis ground to one or 24 volt common to one, should read approximately 2.8. and common to 2 should read 2.2. If you do the math in your head, that's a 0.6 bias or a 0.6 difference. And this is key to a stable network. The mod furnace with a cased coil and a fit inverter, 2.8, 2.2. This is interesting. A 2-stage furnace with the same cased coil and a fit inverter, the network data will read 2.3 and 1.7. This is very interesting, and I'll touch on this for a moment.
Okay.
Now look at the bottom one, a 2-stage furnace with a TXV and the original cube inverter.
Like an 18 or 20 SEER
Exactly.
conventional.
Exactly, sir. The 2-stage furnace is a unusual child in that it's a 3-volt board. It's a 3-volt board.
Oh.
So its voltages are 1.9, 1.3. But if you couple that 2-stage furnace with an EEV cased coil, which is putting out 2.8, 2.2, you have to do the math. So 2.8 and 1.9, add it together, divide by 2, you get 2.3.
Okay.
2.2 and 1.3, add it together, divide by 2, you get 1.7. In all of these cases, it's important to know what these voltages should be, but there's a shortcut. There's a shortcut simply by measuring across the data 1 and data 2. So to troubleshoot and fix the network, make sure you got 24-volt AC at each R and C terminal on each of these circuit boards. This is important.
Sure.
The board won't function without the 24-volt.
Right.
Exactly.
Power for supply.
Exactly. Measure the voltage from the 24-volt common or chassis ground to terminal 1 and 2. If you read the same voltages, that is, I read common to 1, common to 2, and they're both 2.3, your data wires are shorted together. There's a short somewhere. You need to find it and fix it.
Staple in a stud or
wires
that accidentally got put together.
It was pulled across the spot on the ductwork.
Pulling up against the duct. Yeah, absolutely.
If you're reading these bias voltages with your meter, you read common to 1, 2.3, and the other one common to 2 is 0, as common to 2, common to 1. One of these voltages is zeros. Guess what? One of my data wires is broken. One of them is broken. There's an open wire somewhere. You got to find that and fix it. Now, what we do in tech support is we try to do these things really fast. That is, we do a shortcut, read straight across the 1 and the 2, and it will give you the bias, the delta, the difference between data 1 and data 2. And this is ideally supposed to be a 0.6, just a little over a half a volt. So if you read less than that, you know you don't have a short, you know you don't have an open. The network simply needs to be stabilized. It simply needs to be stabilized. So the way to do that is to increase the delta, increase the bias, and we'll show you how to do that here very shortly on the next screens.
Yeah, because I've read in installation and service manuals that the bias voltages, now this is on Daikin, so we're just picking on this one particular brand. You have to check your installation service manuals for the specific brand that you're working with. We're just helping you understand what the technology is looking like. One of the things I've seen in the manuals is that it needs to be 0.6 volts DC or greater. And I never understood exactly what that was until you and I had a conversation, and now it's starting to all make sense.
Exactly. And I use an analogy to make it simple to understand. Now, the network will work. It will operate when the bias or the delta is less than 0.6, a 0.4, a 0.3. Think of the bias or the delta or the 0.6 as a 6-lane highway. I actually need a 6-lane highway for all of the data, all the cars that are moving on this network.
All of our California community, all of our California technicians, they know exactly what we're talking about right here.
Exactly. But if I put the zone controller on, the zone controller increases the number of cars quite a bit. There's a lot more data.
More traffic.
I need those 6 lanes. I need those 6 lanes. I'm liable to have a traffic jam. We've seen the network destabilize even when the zone controller is not there. So it's important to try to achieve your 0.6. Now this graphic right here shows the meter reading common to 1 and common to 2. They both read the same. You see the staple. Now the staple ideally should be across all the conductors, but it's just to show you when you're using your meter, trust your meter. It will tell you when there's something wrong. Now, so you need to find that short. If the voltages read the same, there's a short, find it, fix it, and move on.
Right.
If you're reading one data circuit reads good, say 2.3 or 2.8, and the other one reads 0. You've got a broken wire somewhere. Maybe you twisted that wire nut a little too much. You know,
maybe I pulled that extra inch of control wire out of the wall.
You give yourself enough slack there. Yeah. So find the open wire and fix it. At the end of the presentation, we're going to go over a quick refresher, how to ohm out these circuits and find these opens, find these shorts, okay? Now, this is the shortcut. This is the shortcut.
This is the thing everyone needs to know.
Read straight across the 1 and the 2. Yes. Read straight across the 1 and the 2. Now, notice there's 4 places that you can measure, gentlemen. There's 4 places you can measure.
And ladies.
I should measure if if my network is not stable. I can go to any 1 and 2 on any circuit board. It'll read 0.3. When it is stable, I can go to any 1 and 2 on any circuit board, and it'll read a 0.6. In this case, our network is not stable. Right. It's not stable. It might work, but you might get intermittent issues, comm issues, bad data packets. Best to stabilize the network for high volume of data for lots of cars. Okay.
Yeah, absolutely.
The cars. The next page will show how to fix this. Now, there's 2 ways to fix this. If the zone control is there, use the biasing dip switches at the bottom of the UT-3000 and simply move these 2 on to the right. That will stabilize the network. Now, if you don't have the zone controller, then you stabilize the network by going to the outdoor unit and finding the term dip switches on the 2-stage Daikin Amana equipment, and on the cube inverter and the fit inverter, they're designated DS1. So
not to be confused with DS2, which is emergency mode.
No, we don't want to move DS2.
I might have found that a few times.
And DS1, please.
Good to note that DS1 is not in the most accessible location. The most accessible location you would think is right where you land your power wire. And that cover that is on the side of the unit, that is not. That is DS2. DS1 is actually located on the control board next to the display.
Yeah, and it's, to be specific, the DS1 or the term are typically very close to the low voltage terminal block where the factory black and factory gray wires actually land and terminate. Exactly. Right. So 2 ways, gentlemen. If the zone control is there, biasing 1 and 2 should be on to the right. Term and DS1 should be off. Okay. These are the 2 ways to stabilize the network. Once you do this, then you need to go back and take your voltage reading again.
Right. Now, this is after we have verified that all of our control wire is not stripped. We don't have any corroded wire nuts. Once we have validated that it is not in the control wire, then you can move on to step 2, which is adjusting bias voltages.
Correct. Now, we've gone back. We've checked at the EEV coil. Lo and behold, we have our 0.6 bias or delta. And if I go to the outdoor unit and read it, it will be the same at the furnace or the air handler, or at the zone control system block, or at your thermostat subbase if the zone controller is not there. Correct. Now I can go to the outdoor unit and the display shows E11, which means the system test needs to be performed. The indoor air handler, the furnace circuit board displays on. That is E77 is no longer displayed on the EEV circuit board. And the UT-3000 now shows and
Air
displays a
temperature.
valid outdoor temperature.
Yeah.
Okay.
A lot
Then
of
you
people
know,
ask about that. They'll say, do I have to add an outdoor air temperature sensor to this if they first get that code where they're not reading an outdoor air temperature sensor? And for those people who are familiar with the older Honeywell CTK series and the
yes,
Honeywell communicating systems, the Prestige, where you can add outdoor sensors, a lot of people ask, well, do I need to add that? No, we are utilizing the outdoor temperature sensor of the outdoor unit, one of the many sensors and thermistors that we have on our new inverter technologies. So it is using the outdoor thermistor that is sending a signal to the control board of the outdoor unit, primarily used in defrost and to see when we're going to be able to set our balance point. Now we're going to
exactly,
use it for our entire system, just like
exactly.
in our communicating system. So a lot of our building automations, the world that I came from, if I need to grab a temperature, I just borrow it from somebody else. Not a big deal. And
Right,
that's what we're actually
right.
doing with that sensor.
Thanks for pointing that out because the UT-3000 does have a dedicated outdoor air sensor terminal block at the bottom right corner. And we get this
That's
question a
right.
lot. Do I need to add a sensor there? No, we're retrieving it from the outdoor unit. And this is why it's a good clue. If you see OAS bad, it doesn't mean you need to add one. It means we need to fix
I
and or stabilize the network.
I don't see you yet.
Now here's the EEV board and it's displaying on, and this is a good sign. You see the COM LEDs, the two green COM LEDs are
Mm-hmm.
flashing. This is a good sign that the network is stable and talking. E77 is gone, thank goodness.
Mm-hmm.
The
Yeah.
zone board is showing a valid outdoor
Outdoor
temperature. This is all a good sign that the network is
is
now
talking.
talking. So now can initiate the test. Um,
Some
and
people
you're
may
going to
recognize that as system verification test as well.
system verification test. And it could be a bit confusing because you're going into the equipment test folder in order to find the system test. And we're
Sure.
going to show you the procedure for doing that. And it's going to be done using the UT-3000, not the thermostats, because we haven't connected them. They're sitting on a table somewhere. Normal cooling will not work until this system test is performed. Now, if you're adding the zone control after the fact, the system was already operational, you don't have to do a system test again if you don't want to, but it doesn't hurt to do it.
Sure.
The outdoor unit will run the system test as many times as you want.
Gotcha. And it just sets a good foundation for, are we moving enough airflow? What is our system capacity? Let's ramp things up and down. And that throws people off a lot of times too. If they're doing a system verification test, and this is any manufacturer, we may not start a compressor right off the bat. We may start a condenser fan motor if it's an ECM so we can vary the speed of it and check amp draws. Then we might turn on a compressor and ramp it around a little bit, looking for different parameters of amp draw. Then we might turn on some airflow and open and expansion valves. So we're reading temperatures and pressures to see that the system is compatible and that our capacities are matching properly. So it takes a little while, 7 or 8 minutes on a lot of these.
It does. On average, it takes about 8 minutes or so. And this
Yeah.
is a one really important logical reason why we decided to encourage use of the zone controller rather than the thermostats, because we can guarantee all the dampers are open. All the
Yes.
dampers are open. Some of them are not closed, which could affect the outcome of your system test or your charging mode.
Yeah, just imagine if a system itself is trying to ramp up to 100% capacity and it has dampers closed. What's that going to do to the load on the evaporator?
Yep.
Definitely
Yep.
not going to get a correct reading.
Exactly. So using the zone control, you're simply going to press the up and down buttons right underneath the screen at the same time and release. And the screen will display select the system menu.
No thermostats connected.
No thermostats connected.
Okay.
And lo and behold, you hit the down button and the first piece of equipment has been found. It verifies I have a menu for a furnace.
So
And we can access it if we want to.
Okay, so this goes back to the entire concept of that thermostat not being the brain of the system. The system is the brain of the system. So now, with no thermostat, we're able to go into the zone controller and look at the submenus of the furnace.
And as you pointed out earlier, Clifton, before the webinar started, it is possible for the contractor to go outside and initiate the
System
system
verification, system
test.
test. Absolutely.
But think about it like this. I'm in a crawl space with the zone controller. I don't have to leave.
Right.
I'm in the attic with the zone controller. I can initiate the system test. I don't have to leave. I don't have to put on booties and make sure I'm presentable and clean, and go, which one of the thermostats is zone one. I can initiate the system test right here. I can
Absolutely.
access the diagnostic folders if I wanted to, clear
Yeah.
diagnostic faults, all kinds of things. Anything you can do in the equipment menus with a thermostat, you can use the zone controller to do.
I love it. Yeah, you're inside, you're high and dry. You can put it in system verification test and start taping up seams, sealing ductwork, picking up your tools, not running back and forth, because we have eliminated the perception of requiring the thermostat to do the commands for the system. It's just a component. It receives and it transmits just like everything else.
Exactly. So we saw the furnace, but we don't want to access the furnace. We want to access the outdoor unit. So you keep hitting the down button and it will show you what is not on the equipment network. There is no air handler. Yeah. Of course not. We found a furnace, so there is no air handler. There's no air conditioner. So we keep hitting the down button. And lo and behold, we found a heat pump. That is the UT-3000 found a furnace and it found the heat pump. This is not shown in this presentation, but if you hit the down button again, it'll show that it also found the electronic expansion valve coil.
That's right.
If you tried to access it, you won't, because that's all super top secret stuff.
There we go.
It won't let us in there, but it will let us into the heat pump. So we found the heat pump. Now we press the right button one time only. When we do, the UT-3000 will ask you to wait a second. Wait a few seconds while I talk to the heat pump and I retrieve all of the heat pump menu folders for you.
Hey, Bob, how are you out there? What size are you, by the way?
So it only takes a few seconds and the screen will change. The very first folder you'll see is the configuration folder. If you keep hitting the down button, you'll see the diagnostic folder. Notice that a lot of these folders are abbreviated. You keep hitting the down button, you'll find the system setup number 1 folder. You'll find status, system setup number 2 folder, all kinds of cool stuff to access. But keep hitting the down button because we're looking for the equipment test folder, and there it is. So once I see equipment test, what do? Hit the right button to access it. And the UT-3000 will ask you to wait for a few more seconds while it gains access to that folder. And lo and behold, there it is, the system test. Now, if I hit right to access this test, the very first thing it'll show me is that the test is off. Notice the asterisk. This means the system test is not running. I hit the down button one time to find on. And there it is. I hit the right button again one time, and the UT-3000 will say, I'm updating the system.
And in other words, away.
It's asking the heat pump, I want you to run the system test.
Yes.
So now you leave the buttons alone.
Yes. No more touchy. That's the big thing that I've ran into. People going back and hitting buttons and now stepping out or canceling that process or not getting a complete validation.
Exactly. So now you'll see on the screen the word on with asterisks, just like you saw off with asterisks. Now you'll see on with asterisks, meaning that the UT-3000 has requested of the EEV and the heat pump, would you please run the system test? And now it's going to do it. So leave the buttons alone. Don't interrupt the test. Go eat a sandwich or something. Clean up the work area a little bit. Do not mount the thermostats on the wall plates just yet. Because if you do, grandma might ask for heat and close some dampers somewhere.
Exactly.
Her damper will remain open, but somebody else's dampers
One
are
of the
going to
other
close.
zones are going to close off.
Don't want to affect the outcome of the system test. So
Right.
8 minutes, 15 minutes, clean up the area a little bit, and then come back. Now, you'll know this test is done because the equipment will simply go idle.
Right.
And the E11 display outside is gone.
John, one thing that I have encountered in this process, and I would like to just validate it. I should have asked you this beforehand, but one of the scenarios that I have seen is if a system is going through a system verification test, a run test, and it takes longer, say it takes 30, 45 minutes, is that a good indicator that if we were to step back and check our bias voltages, those bias voltages are probably going to be low?
It is, Clifton, and that's a good point. Remember, when the network is not stable, everything's moving slower. You might have bad data packets, and bad data packets gets thrown away, and then they have to be renewed and refreshed.
Right.
Okay, so a long system test is an indication that there could be an unstable network. It could also be an indication that you did not put in a proper oil trap. Okay. The initial charge may not be correct. Remember, I think there's enough refrigerant for 25 feet of pipe. If I had much more than that,
unless it's a horizontal coil, then it's slightly different, but not much.
Yep. So that's a good point. That's a good point.
Yeah.
So do not mount the thermostats just yet.
Right.
So that was commission 1, which is done. Now, if we want to, we can go into commission 2. A lot of guys just go ahead and start operating charge mode later. I highly recommend you do it now. Now, remember, charge mode is 1 hour, 1 hour. So after the system test is done, you're going to re-enter the heat pump menu just like you did before. Navigate to the system setup 2 folder.
Okay.
Then once you access that folder, hit the down button, find charge mode, hit right, you'll see off. Hit down, you'll see on, hit right again, and lo and behold, you're in charge mode now. This is another good reason not to connect any thermostats prior to this.
Sure. Don't want to interrupt. Actually, we just got a question about that, John. This is a good time to maybe address that. So say someone has initiated a system 1 startup, so a system test, and in that process, we lose power. Say somebody is, working on the outdoor unit and they're buttoning things up and they accidentally pull the disconnect, or say we're in the middle of a system test and we lose power. Will we be able to restart that system test once we have reinitiated the system?
Yes, you will. Yes, you will. Once the power comes back on, I imagine this does happen, and that's an excellent question. If in the mind of the outdoor unit, the system test was incomplete, it did not get to finish, the E11 is not going to go away. So once you restore power, you're simply going to have to start the process all over again and achieve a successful system test. That's an excellent question.
Okay. So we're in charge mode.
Mode. And remember, charge mode is an hour, and it may not take you an hour. You don't have to wait the entire hour. If you finished, your subcooling is good. The very cool fit inverter told you your subcooling is good. You trimmed your charge a little bit. You finished in 20 minutes, 30 minutes. I don't know. Simply use the buttons, go back into the system setup 2 folder, go back into the charge mode, and turn it off.
Wow.
Okay.
So we have commissioned a piece of equipment. So we're talking a communicating inverter outdoor unit. Say we've got it connected to the highest capacity, 97% modulating gas furnace. We have our communicating zone control board, no thermostats connected. We have done a complete commissioning. We've done a complete system charge.
All without any thermostats connected.
Love it.
Yeah. Okay, so commission 3, and all total, we've probably been doing this for less than an hour.
Oh yeah,
The
absolutely.
system test and the charge mode completed, maybe 40 minutes, maybe
Yep.
45 minutes, maybe an hour, maybe
Yep.
less. So now, last but not least, is configuring the stats. Now, thank goodness, I can finally put the thermostats onto their respective sub bases
Right.
and configure them, which is also a bit of a process. We describe how to do this in our literature. Daikin also describes how to do this. The logic or the reasoning behind this is because the Daikin 1 thermostat, some of us know, some of us may not know, is continually polling the equipment for data that it wants to retrieve.
Right.
So, in order to accommodate this and facilitate it, the Zone 1 thermostat is the only one that's allowed to poll for data.
Right.
So the zone controller has to be added to each respective thermostat, and you have to designate the Zone 1 thermostat as Zone 1
Yep.
and any additional zones or Zone 2 and up
As
as
additionals.
additional zones.
Sure.
These Zone 2 and up are not allowed to poll for data, only Zone 1 is. So this last commission process is very easy to do. You use the thermostat to do it. You go into configuration, dealer edit, go into the equipment folder, find the EWC zone control.
And it'll
Just
be
like
there waiting.
exactly, just like if you were adding a humidifier,
Yeah,
you're
exactly.
adding the zone control.
Yep.
You're simply designating one stat as zone 1 and the others as additional zone. Now, not to be confused with naming your thermostats.
Oh, true.
You can name these thermostats
Yeah.
master
Basement,
bedroom,
master, second
dining
floor.
room, kitchen, basement,
Sure.
what have you. This is simply designating which thermostat is zone 1. And this is another reasoning or logic for letting the zone control commission your equipment. I don't have to leave the attic. I don't have to go find which thermostat was zone 1 again, because zone 1 is the one I'm supposed to use to initiate this test. So this is a real time saver, we're hoping, a real labor saver. And it all comes down to money. It all comes
Sure.
down to money. Time is
Time
money.
is money.
So we're really hoping that everybody will utilize this. The documents, the hyperlinks, one of them is this exact procedure. So we're hoping that you'll keep that with you. Keep it on your phone, keep it in your van, your work truck, so you can reference it whenever you need to. Share it with your fellow contractors. It's great information, and we hope we're going to save you a lot of time. I really appreciate you attending the seminar, and we hope that everybody learns something that they could use in the field, because that's the entire goal.
That's why we're here.
Entire goal.
It's about educating an entire community and bringing in the professionals from every aspect of that community. That's the reason we started this entire Did You Know series, thinking, wow, wouldn't it be amazing if we could bring in the top educators from every aspect of the industry, bring them into places where they have the opportunity to discuss these topics. So now you're getting credible information directly from the first hand of what you're going to see, but not only what you're going to see, but why you are seeing it. And
Exactly. As far as any other manufacturer goes, it really comes down to knowing, as we pointed out to you, what are these voltages supposed to be?
what is
What
your
is
network?
my bias supposed to be? And
Right.
it all comes down to, if I know that and I use my voltmeter, it's simply a matter of proper wiring, good practices, using the voltmeter. I don't know how I don't have to know the hierarchy. I don't have to know how that data is moving. All I have to do is give it a proper highway.
That's
I just
right.
have to give it a proper highway to move, and it will work. It will work.
And it follows so many other curriculums. If we look at a telephone repair technician 30 years ago working on the same RS-485 platform, his most important tool, the voltmeter.
Exactly.
If we talk to a computer technician working on a Ethernet connection running on RS-485 platform, what is his most important tool? his meters.
Voltmeter.
So in
Exactly.
our industry, we follow the exact same protocol. We have a 5-volt DC communicating protocol. If we know what the voltages are supposed to be, you will be successful at figuring out why things aren't functioning properly. And that has been the biggest complaint of technicians. So we have picked on one brand today. We've picked on the Daikin using the Comfort Net system, which is part of our 5-volt DC system that's been around since the 1980s. We're talking about climate talk. And there are many manufacturers that follow along that same philosophy. Now, they might speak different languages. They might have a different accent to their language. If we were to use an oscilloscope, we could start looking at that, because a lot of times we're just looking at ones and zeros. We're talking about coding. We're talking about if I have voltage, I have 1. If I have no voltage, I have 0. And in the distance that I have voltage, I can use Morse code and I can say things. And that's what we do. But we're not going to dive into that, because as technicians and as students and as educators, the important part is, do I have my highway? Can my lines of information travel on the line set? John Brown, you're an incredible asset to the industry. I encourage everyone to check out EWC. The many things that EWC offers to the industry that most people don't know about. And this one is an incredibly important one. And I'm so grateful to know you and the things that you have taught me. And
thank you very much, Clifton. You're way too generous. Now, before we go, I promised them a quick refresher on how to ohm out your circuits. Okay, how to ohm out your circuits.
Yes.
You'd be surprised how many guys think this is a difficult thing to do. It's really not all that difficult. Now, granted, you got to disconnect things, you got to set up your meter and so forth. But even brand new cables that have been routed into a home can be compromised quite easy by staples, sharp edges on the duct, nails, and so forth. We all know this. We don't want to, admit it, but it does happen.
Happens.
So there are 3 tests to confirm a cable is adequate. That is, that it is a good wire set. The very first one is a shorted wire test. We set our meter to continuity mode. We put our probes together. We get a beep, and we disconnect all the wires at one end and leave them hanging in the air, and disconnect all the wires at the other end and leave them hanging in the air. Now, this wire is only a couple inches long, but this wire
represents
could be
250 feet on some of these outdoor applications.
Exactly. So with the meter, we confirm we get a tone by putting our probes together, and then we read every wire to every other wire, every possible combination. We should read infinity. That is no tone. No tone. I know none of those wires are shorted in the jacket, and nobody got happy with the stapler.
Exactly.
Okay. So
if
that's
we
test
have
1.
resistance, we will show some continuity, which means we have touchy. We don't want touchy.
Exactly. Then there's somebody got happy with the stapler, or somebody got really lucky and hit it with a nail.
Oh, yeah.
What are the odds of that? Right?
Well, it can happen. Absolutely.
So the next test, the wires are still hanging in the air. This is the one a lot of guys forget about. This is measuring each wire in that cable, in that jacket, to earth ground. Okay, so once again, I need to be near some earth ground. That is the line set, ductwork, some unpainted metal that I know is earth ground in that home.
Metallic,
and I'm measuring
water line.
earth ground to every wire in that cable. Once again, infinity, no tone, no beep. I should read infinity, every wire in that cable to earth ground. That's a good second test.
Yep. Here in the Midwest, when we have a basement with a sump pump, we have no other, a lot of our installations now we're using, poly and PEX water lines and gas lines. You got a sump pump, you grab your piece of copper wire, you strand it, and you shove it down into the water, and now you have a good, clean place to measure ground. So plenty of places we can find good ground.
Good point. Thank you. Okay, so last but not least, the third test. Are any of these wires compromised? That is, are they open inside the jacket?
Internally.
It's rare, but it can happen.
Oh, yeah, it can happen.
So I go to one end and I twist all of them together. I strip down to good, clean copper, like Clifton said. Twist all of them together. Don't over twist. twist all of them together, go to the opposite end where they're hanging in the air. I should get tone on every wire to every other wire.
Exactly the same. We're the same distance. We're traveling the same amount of distance on the same diameter copper. We should have the same resistance across same impedance.
Exactly. So don't forget these tests, gentlemen. They're extremely important. I like to tell guys, when all else fails, ohm out your wire set.
That's right. I agree. Or throw a fresh one out the window and door.
Exactly. And that's a good point. Throw it out the window around the house, and lo and behold, it works. You know your wire set is compromised. Exactly. Here are these very important hyperlinks, gentlemen. Take a screenshot. All of these are available for download at the EWC website, with the exception of the Daikin one. Now, also, each one of these documents, that is the technical bulletin for the UT, the commissioning startup guide, the guide on how to use the buttons, are also available in Spanish. Okay.
Oh, wonderful.
For download at the website. So go to the website, navigate around there, go to manuals, go click on the letter U for the UT-3000. You'll find all of this stuff right there.
Love it. All right, a little bit of time. If anyone has any questions they would like, I'm sure a lot of brains are just going poof, and some of them are going, oh my goodness. I wish somebody would have told me that a long time ago. Such an important topic.
As I said, once again, it's really important. No matter what manufacturer's communicating equipment you're working on, these communicating systems are not going to go away. The higher the SEER requirements, and the government's about to release SEER 2,
that's exactly
the more prevalent these communicating systems are going to become, because you can move a whole lot of information, a whole lot of data. You can have high SEER multi-stage inverter proportion equipment with just 4. Not going to go away. No matter which manufacturer you're working on, if you know what the voltages are supposed to be, and if you know what the delta between these data lines are supposed to be, you can create a good highway and a stable highway for the data to move on, and your system will function.
John Brown, EWC Excellent Without Compromise. Once again, thank you.
You're welcome, Clifton. Thank you very much. Thank everybody. Thank you, everybody.
Everyone have a wonderful evening. We'll see you again next week on Did You Know? The ESCO HVAC Show. Thank you for joining Did You Know? The ESCO HVAC Show. You want to see some of these great presenters in person? Well, then we'll see you at the National HVACR Educators Conference, where many of these guests will be presenting live classrooms, and you'll have a chance to interact with them. Would you like to watch this show again? Hey, no problem. Just head on over to YouTube to ESCO Institute. Do you have a topic that needs clarified about some kind of a change in the industry? Well, then let me know. See Beck at escogroup.org, and we'll see what we can come up with.